Hello everyone, we will be presenting on artificial intelligence and data science for air pollution, prediction, and visualization. Our advisor is Mohammad Pourhomayoun, and our sponsors are NASA and LA City. Next slide. Air pollution is when pollutants are released into the air and are harmful to the health of humans and to the planet. These pollutants are a mix of particles and gases. Los Angeles is known for its smog, which is formed by the combination of particulate matter 2.5 and ozone. Smog, also known as ground-level ozone, occurs when emission of fossil fuels reacts with sunlight, while soot, also known as particulate matter, is made up of tiny particles of chemicals, soil, smoke, dust, or allergens, in the form of gas or solid, that are carried in the air. Other forms of air pollution are black carbon, which is one of the components of particulate matter. Nitrogen oxide and nitrogen dioxide are air pollutants. Nitrogen oxide is rapidly converted to nitrogen dioxide in sunlight, while a combination of the two can lead to very serious health problems. Another air pollutant is sulfur dioxide, which again, like black carbon and ozone, is emitted into the air by burning fossil fuels, but sulfur dioxide is emitted when it burns a fossil fuel that contains sulfur. The most common cause for air pollution for particulate matter comes from burning fossil fuels by power plants, automobiles, non-road equipment, and industrial facilities, as well as from dust and diesel emission, while secondary particles are formed from gases and vapors. For black carbon, it will be burning fossil fuels, as well as such as diesel, wood, and carbon. For nitrogen oxide, the primary emission will be from transportation, from automobiles to buses. Pretty much any form of transportation, it will create a high concentration of nitrogen oxides. For ozone, it will be a combustion of fossil fuels. While finally, sulfur dioxide will be from burning fossil fuels that contain sulfur, which will be from coal, metal extraction and smelting, ship engines, and diesel equipment that burns fuel that contains sulfur. Next slide, please. So now, before I talk about common air pollutants that affect us, I can say that air pollution is detrimental to the human health as well as to the planet as a whole. Since air pollution is not the biggest environmental risk for early deaths, because of it's responsible for as many as 5 million premature deaths each year, the causes of it are from heart attacks, strokes, diabetes, and respiratory diseases. Besides those impacts, air pollution is also known to impact our mental health and our work productivity. So now as we focus on our own location, Los Angeles Air Quality Index in 2019 varied from 32, which is considered good, to 64, which is considered moderate. Los Angeles air quality averages an index rating of moderate. Even though the city's air quality is average at a moderate, its air pollution is still one of the worst in the United States for particulate matter 2.5 and ozone. Now, since particulate matter is one of the worst pollutants in Los Angeles, I will begin to talk about the problem it can cause. Particulate matter 10 is known to cause nasal and upper respiratory health issues, while fine particles less than 2.5 microns in diameter, or particulate matter 2.5, can penetrate deeper into the lungs and cause heart attacks, strokes, asthma, worsening bronchitis, premature death, lung disease, and cancer. It is also known that high exposure to particulate matter 2.5 can impair brain development in children. Next slide, please. The general effects of air pollution can vary based on short-term and long-term exposure of certain pollutants. The effects of smog, also known as ground-level ozone, has been known to be the case of respiratory irritation. The short-term exposure of ozone can cause respiratory irritation, which is chest pain, coughing, and eye, throat, and skin irritation, while the long-term exposure can lead to decreased lung function and cause chronic obstructive pulmonary disease, and can also aggravate existing lung disease. Black carbon is a serious health threat because if there is a long and high exposure of black carbon, individuals are at high risk for heart attacks and strokes. Black carbon is also associated with hypertension, asthma, chronic obstructive pulmonary disease, bronchitis, and a variety of types of cancer. Nitrogen oxide effects are the development of asthma and bronchitis, as well as high risk of heart disease, while the effect of sulfur oxide emissions that are located in the air are eye irritation, asthma becoming worse, and increased respiratory infection, and impact to the cardiovascular system. Next slide.
Air pollution in Los Angeles. Air pollution is an enormous health hazard for everyone in Los Angeles, and it continues to get exponentially worse every year. It puts those who have respiratory illnesses at risk, and it continues to hurt people's daily lives. The U.S. Environmental Protection Agency identifies Los Angeles as not meeting its air quality standards for several pollutants. So how does this affect us? will affect our entire ecosystem, our environment. An increase in air pollution will further accelerate the climate change taking place here in Los Angeles. There's an abundant amount of scientific research articles that show the direct correlation between air pollution and climate change. Likewise, for air pollution and health, high temperatures and droughts are likely to increase the severity and frequency of wildfires, which will negatively impact our air quality. Many states in the west of the US, especially California, are prone to wildfires. 2020 was just an example of how bad these fires can get. The August Complex Fire was one of the worst wildfires in California to date and emitted a tremendous amount of air pollutants in the air. Los Angeles County remains one of the most polluted regions in the nation. So, what is the significance of this? Air pollution in Los Angeles has had negative impact on people's lives and causes respiratory illnesses affecting both children and adults. Exposure to air pollution is a concern in urban areas like Los Angeles because of the high dense population exposed to air pollution and a high number of emission sources. Respiratory and cardiovascular disease caused by air pollution is one of the most critical health problems worldwide. Ambient air pollution and particulate matters have been closely associated with adverse health effects such as exposure to disease and cardiovascular diseases. Previous studies have examined the adverse health effects associated with short-term and long-term exposure to ambient air pollution and outdoor particulate matter on respiratory diseases. Here are some statistics from LA County. Asthma statistics in LA County: 1 in 11 children have asthma, which is 9% of the population. 1 in 14 adults have asthma, which is 6% of the population. Cardiovascular disease statistics in LA County: per 100,000 population, heart disease accounts for around 150 deaths. Knowing the effects of air pollution, what are our goals and purpose for our project? So our goals is to develop a data-driven platform and web application as a dashboard to address the issue of air pollution. Our goal is also to develop an app that has user-personalized features along with a forecast of air pollution in their area for the next few days. What is the purpose? It's to give users general information surrounding air pollution and its effects, and to allow users with conditions such as asthma to plan accordingly based on the forecast.
So some of the best parts about being able to work on this project is that we get to use and learn new technologies that we otherwise wouldn't have. So some of that includes Python, which is to be used for the machine learning models for air quality predictions and forecasts, Java and Android Studio, which we use to develop our mobile application, and HTML, CSS, JavaScript, which are the main tools for building web applications. We also use React, which was our framework of choice. And then we also had the Esri and ArcGIS, which provided the amazing libraries that we were able to develop meaningful and interactive maps with. Next slide, please. Okay, so the current state of things of our web application and our dashboard is that it displays air quality and weather of the current location. It contains the set of 2 maps you can toggle on and off data sets. It contains set of graphs for air quality trends and information, and also contains a list of articles that is closely related to air pollution. Next slide, please. So here we have the component that displays air quality and weather of the current location. As you can see, it displays the current location along with the measured air quality index and a 5-day weather forecast. So we were able to develop this with the help of an API that we used called Open Weather Map. And although in the screenshot you see that it is centered around Los Angeles, but you are capable of changing the location, and the component will change in response. So, if, for example, if you chose Alhambra, for example, it would change to that location, displaying a new air quality index and a new 5-day weather forecast. Next slide, please. So this is just another component that displays the varying levels of air quality and what they mean. So just displaying a number really has no meaning on its own. We need it to connect to something. So for example, in the previous slide, it showed that Los Angeles had an air quality index of 54. So by using this chart, we can pretty much see the level of concern and the description. So in this case, the level of concern would be moderate, which means that its air quality is okay, but it might be it might be bad for people who have sensitive issues such as asthma or something of the like. Next slide, please. Okay, so this is an example of one of our developed maps. It displays the current air quality in certain locations. So as you can see on the left, you can see that the user is capable of toggling on and off these data sets. So if they wanted to see just one specific data set on its own, they could toggle off all the other ones and just see that one on its own. Next slide, please. Okay, so this is another one of our developed maps. This one displays the common causes of air pollution around Los Angeles County. So again, the user is capable of toggling on and off these data sets. So if they wanted to see just the transportation line across Los Angeles County, they would toggle off everything else and they just see that. And these maps we were able to create these maps using the Esri and ArcGIS libraries, and the data sets also come from ArcGIS themselves. Next slide, please. Okay, so this is a component that we have developed that displays the current articles pertaining to air pollution. So it gives the title of the article, the used image, as well as a short description. And we always link it back to the original source so that if the user wants to be able to read more about the situation, say in Colorado or something like that, they would be able to go back to that original article if they want to read more about it. And this component was made using a web search API that extracts articles based on a keyword that we give it. Next slide, please. Okay, so this is an example of one of the developed graphs that we were able to make using the Canvas.js library. So this graph in particular displays the current air quality that is measured. So there are a few tabs at the top for more specific locations, such as 3rd and Broadway or Memorial Coliseum. So we were able to get information on these specific locations using the OpenAQ API. But the main tab, the first tab, generally centers on general Los Angeles, and we were able to get that information using the Open Weather Map API. So as you can see, the API generates, or the graph shows the 6 main air pollutants in CO, NO2, SO, PM 2.5 and such. So it shows varying levels and also does that for the specific locations as well. Next slide, please. So this is another graph. Again, it displays the air quality, but instead of the current air quality, it displays air quality trends over the past few days, as well as the past few hours. So you can see sort of the changes in air quality over time. So again, it is centered around the general Los Angeles area, but there will be tabs that you can display information on, specific areas. Next slide, please. Okay, so this is an example of, one of the other graphs that we're able to make as well. And we were able to make these graphs using information from EPA and WHO. So as you can see, these graphs, we are capable of showing, which sector had the most greenhouse gas emissions and what depths were most attributed to ambient or outdoor air pollution. So we were able to show this information to sort of inform the user which areas especially in which areas create the most greenhouse gas, and then which out of all the depths, which depths are most attributed to ambient or outdoor air pollution. Okay, next slide, please.
So moving on, we are going to be talking about the mobile application and a little bit of background as to why we decided to make it. So to begin with, air pollution data is not very user-friendly. There are a lot of definitions people are unfamiliar with, and it can be sometimes hard to make sense out of all these numbers and data. There are web applications that are pretty useful or can be useful, but they're not always easily accessible, and to the average person, they might not have access to a computer at any given time, or they might not have a computer, which is something to also account for. So we decided to make a mobile application using Java to create an Android-based app that will be able to display this air pollution data effectively and efficiently. Next slide, please. So now we're going to be talking about the specific purpose of the mobile application and what it's designed to do. So we want to be able to track certain air pollutant levels throughout different regions. Not only do we just want to be able to display data for the location of the person, but we also want to be able to display data throughout many regions and a vast amount of regions. We want to be able to provide different levels of air quality pollutants using the ArcGIS database. So the ArcGIS database is a very strong foundation of data, which we build upon to be able to allow users to interpret and display this data. We also want to be able to accurately predict air quality data in the future using AI. We do want to be able to not only show the current air pollution data to the person, the previous air quality pollution data to the person, but we also want to be able to kind of like forecast this data to the user. And alongside that, we do want to be able to make it convenient for the data to be accessed, because otherwise it'll defeat the purpose. Next slide, please. So currently, this is what we've done and how it has helped. So we have already created the mobile application that does display this air pollution data. We have been able to create a login database system, which allows us to be able to identify the user and kind of give them a little bit more of a catering aspect to it. So that way it's more based on the user rather than just a general person accessing the database. We are able to display news that helps with the air quality pollution data and kind of adds to the amount of information the user has access to. And we were also able to create a dashboard that does allow for the user to track further air pollution, such as certain levels of air pollution. Maybe they want to see certain types of air pollution data. And all of that can be done very easily on the app and very conveniently. Next slide, please.
So I'll be talking about some of the functions of our mobile app. We first start here in the login screen. As you can see from the background logo, we designed it to have some relevance to air quality. So starting here, if you are a new user, you can register through here from the new user register here link. It'll take you to a place where you can register with an email and password. Once you are registered, it should automatically log you in for the first time. Any existing users will have to log in with their email and password again if they log out of the app. Next slide. So once you log in, you'll be taken to the map tab of the app. This is the default tab that the login screen will always take you to when you first log in. You will have a map with a data layer taken from the ArcGIS database. That layer is provided by the Office of Air Quality and is updated once every hour. You can see all these points here, that's all the locations that will tell you some air quality information. The map also contains this search bar, as you can see from up here. To use it, you just simply need to click the hourglass icon in the top left and search up an address. You can be as vague or specific as possible when searching for an address, so typing in something vague like California, or typing in something super specific like the entirety of the school's address. It should work either way. So we're moving on to the next tab. Next slide. Next tab I'll be talking about is the City Dashboard tab. This tab will allow you to keep track of air quality in cities that you add into the dashboard. So you are given the option to add or delete cities from your personal dashboard. To do so, all you need to do is, for adding cities, you just need to press the plus button in the plus button in the top right. And for deleting cities, all you need to do is press the X on the top right of each card. As of now, however, the app is only currently restricted to cities in California only. So let me explain a little bit about cards. When you added a city, a colored card detailing some of the city's air quality data will be displayed along with some other relevant data such as weather, wind, humidity, and pressure. They will all be on the card for that city. The card's color is determined by the air quality. So as you can see in Los Angeles, the AQI is like 48, which is good. So if the card's AQI is low, it will have a green color. And depending on how high it is, it can also become yellow or red. So moving on to the next tab, next slide. Moving on to the next tab, we have the Air Quality News tab. This tab will display several news articles regarding air quality. It uses the web search API to gather these articles and show it here. The news articles gathered will be recent, so it's not going to be outdated or anything like that. It'll always take the most recent articles related to air quality and show it here. To use this, all you need to do is if a news article interests you, you just simply need to press the article or click the article you're interested in, and the app will open a browser directing you to that article for you. So now we move on to the final tab. Next slide. We have the profile tab. This tab will display information at your location. So what I mean is that when you first enter this tab, it will ask you for your location and or ask you permission for your location. And when you accept it, it will pinpoint the city that you're currently in. So a card similar to the dashboards card will show you a card of the city that you're currently in, along with a mini map similar to the map tabs that will show the city and any data points the city is near. So for example, if you lived in Los Angeles, the information displayed will be a Los Angeles card with its air quality data and everything, and a mini map overview of that city, along with any points that are near at the moment. So that will be all of the tabs, and I'm going to pass it back over to Larry for the next slide.
So now we are going to be talking about a little bit of the future goals that we have in place for both the web application and the mobile application. Starting off, we are going to be talking about the web application. So for the web application, we do want to be able to add more detailed maps. We do want to provide more functionality. We do want to make the user be able to access all of this data very easily and effectively, further allowing more tools, further allowing more features of selection. And we also want to be able to add more data. So like previously mentioned, we do want to be able to add prediction for this data of air quality. We are going to be using the AI software and using it within the web application to predict the air quality data. And we want to be able to do this using real time. We want to be able for the database to update itself pretty frequently, so the user will always be up to date with the current information. Moving on to the next slide, please. And now we will be talking about the future goals for the mobile side of the project. So for the mobile side, we do want to add more GUI elements. We do want to be able to add more buttons for different map information types. For the types of air quality pollutants such as the ozone, PM2.5, and PM10, we want to be able to let the user click and choose what he or she wants to be able to see or display. And once again, we do want to be able to display the real-time data. Like I said, for the web and mobile, they are kind of working together, but it's going to be different platforms, and one is more inclusive than the other, but both will be able to ultimately display the same information. In terms of the app data, we once again want to be able to include the predictable AI system in the mobile application. So they'll be able to unanimously do the same thing. And we do want to be able to provide an in-depth information guide of specific points. So we want to allow the user to specifically look up certain locations and check the air pollution quality data rather than it just showing the air quality data around them. As also previously mentioned, we are going to be using an Android or are using an Android software to make the application, but we also want to incorporate the iOS users because we do know there is a large amount of people that are on the iOS platform. So we do want to be able to integrate it into the iOS database as well. And that concludes our presentation.